Welcome back, everyone, to the Deep Dive. Today, we are going deep into the world of your immune system,
Yes.
specifically to explore some super important cells called T helper lymphocytes.
Absolutely.
These cells are like the conductors of your body's defense orchestra, and we want to give you a clear understanding of how they work.
Yeah.
We want to know, like, where they come from,
Right.
what flips their switch to activate them,
Yeah.
what diverse roles they play, and how they keep your immune system in check.
Yeah.
All without overwhelming you with a ton of jargon.
Right.
We are diving deep into detailed lecture notes
Uh-huh.
that break down the creation, activation function, and regulation of these incredible immune cells.
Yes, exactly.
So your mission, should you choose to accept it, is to walk away with a clear, concise understanding
Yep.
of these multifaceted players that are so vital to your health.
That's the goal. We have a pretty comprehensive overview here,
Okay.
covering everything from their origin story to their amazing teamwork in protecting the body. The aim is to distill this complex topic down to the key insights to give you a real grasp of what these T helper cells are all about.
Excellent. So where does the story of these T helper cells begin?
Well, it all starts in the bone marrow. It's like the central production hub
Okay.
for all the different types of blood cells in your body.
Okay.
And within the bone marrow, we have these incredible hematopoietic stem cells.
Yeah.
They are basically master cells capable of giving rise to all the various components of your blood,
Oh, wow.
including the precursors to our T helper cells, which we call lymphoid progenitors.
So the bone marrow is the initial starting point, the
Yeah.
foundation.
Yeah, you got it.
What's the next stop in their development?
So from the bone marrow, these lymphoid progenitors take a trip to a crucial organ called the thymus.
Okay.
This is located in your chest, and you can think of the thymus as a specialized academy, a school specifically for T cells.
Interesting.
It's here that these progenitors undergo a process of differentiation and maturation, transforming into what we call naive T cells.
Naive. Now, naive in this context just means that they're ready and able to recognize potential threats, but they haven't actually encountered one yet.
Okay, so they're like fresh recruits.
Exactly. And it's important to note that the T cells we're focusing on today, the T helper cells,
Right.
are a specific type known as CD4 plus T cells.
Got it.
And they are equipped with a unique recognition tool called the T cell receptor, or TCR.
So the thymus is where they get their initial training
Yep.
and their identification badge. That's CD4 marker.
Precisely.
Now, the notes mention two very important selection events that take
Yes.
place in the thymus. What's the purpose of this double check?
It's a rigorous quality control system. You can think of it that way.
Really?
The first event is called positive selection. And here's what's fascinating. Only those T cells whose
Right.
TCR can bind to your own MHC molecules are allowed to survive.
MHC.
MHC stands for Major Histocompatibility Complex. These are like little cradles
Fact.
on the surface of your cells that present tiny fragments called antigens for the T cells to inspect. If a T cell's TCR isn't even capable of seeing the NHC,
Okay.
which is the language your body uses to communicate about potential threats, it doesn't graduate from the thymus.
So positive selection is about making sure they have the basic ability to see what they need to see.
Exactly.
Okay.
It ensures the T cells can even participate in an immune response.
Makes sense. Then comes negative selection, which sounds like it's all about preventing problems.
Absolutely. Negative selection is the body's way of preventing autoimmunity, which is when your immune system mistakenly attacks
Right.
your own healthy tissues.
Yeah.
During this stage, T cells that bind too strongly to your own self-antigens,
Got it.
which are the normal components of your cells,
Okay.
are eliminated. This is super crucial.
Yeah, I can see how that would be a problem.
If these self-reactive T cells were allowed to roam free, they could wreak havoc.
Yeah.
So negative selection is like a loyalty test.
Okay.
The thymus is checking to see if the T cell is too reactive to your own body's passwords.
Which are those self-antigens. If it reacts too strongly, it's eliminated to prevent friendly fire.
Wow, that's incredible. It's like a built-in safeguard.
Exactly.
So after successfully navigating this double selection process,
Right.
what happens to these newly trained naive T cells?
Well, once they've passed both positive and negative selection,
Okay.
these mature but still naive T cells leave the thymus, they enter the bloodstream and start circulating throughout your body,
Okay.
traveling through your lymph nodes and other secondary lymphoid organs. They're essentially patrolling,
Right.
waiting for their specific antigen to show up. This is like the signal of a particular invader.
So they're out there like sentinels on patrol, waiting for their specific target.
Exactly.
What actually triggers them into action?
Okay, so The lecture notes mention that a naive T helper cell needs 2 signals to
Okay.
become activated.
Yeah, why 2? Is that like a safety mechanism?
You're exactly right. It is a crucial safety mechanism. A naive T helper cell requires 2 distinct signals to become fully activated.
Got it.
The first signal is all about recognizing a specific threat. And this happens through an interaction with special immune cells called antigen-presenting cells, or APCs.
APCs.
APCs include cells like dendritic cell, macrophages, and B cells.
So these APCs are like the intelligence gatherers of the immune system?
Yes, exactly. They capture foreign invaders like bacteria or viruses,
Okay.
break them down into smaller pieces called antigens,
Right.
and then they present these antigens on their surface bound to those MHC class II molecules we talked about earlier.
Okay.
So this is where the amazing specificity of the T cell receptor comes in.
Uh-huh.
If a circulating naive T helper cell comes across an APC that's presenting an antigen, its TCR recognizes.
Right.
And it has to be a super specific fit, kind of like a fingerprint reader,
Oh, wow.
recognizing a unique pattern.
Okay.
This triggers the first activation signal.
So the first signal is like the initial alarm bell.
Exactly. The T cell recognizes a potential threat.
Okay, but what about the second signal? Why is it so important?
The second signal is known as co-stimulation, and it's essential for preventing accidental activation.
Okay.
Imagine if a T cell went into full-blown attack mode every time it encountered an APC displaying some random fragment.
Right.
That would cause a lot of unnecessary inflammation and could even lead to autoimmunity.
Yeah, that would be bad.
So co-stimulation provides that crucial confirmation. On the surface of the APC,
Yep.
there are co-stimulatory molecules such as CD80 and CD86.
CD80 and CD86.
When the TCR binds to the antigen MHC complex,
Right.
these co-stimulatory molecules on the APC bind to a receptor called CD28 on the T helper cell.
CD28.
And this interaction delivers the co-stimulatory signal. It's like a double check.
I see.
Think of CD80 and CD86 on the APC as the confirm buttons,
Okay.
and CD28 on the T cell as the authorization slot. Both need to connect.
So both the specific recognition of the antigen and this co-stimulatory signal have to be present for the T helper cell to say, okay, this is the real deal. It's time to mobilize.
Precisely. It's a two-key system for launching an immune response.
Interesting.
Once both signals are received, the naive T helper cell is fully activated.
Okay.
This is a major turning point. The cell starts making lots of copies of itself, meaning it proliferates, and it begins to differentiate into those specialized subsets.
Oh, yeah, the different kinds of T helper cells.
Exactly.
The notes detail TH1, TH2, TH17, TFH, and TREGs.
Right.
That's quite a diverse group.
It is.
What determines which path an activated T helper cell will take?
Well, the differentiation pathway is really fascinating.
Right.
It's mainly influenced by the specific signaling molecules called cytokines.
Cytokines.
Yeah, these cytokines are like chemical messengers that are present in the immediate environment where the T cell is being activated.
Okay.
They're released by other immune cells and even the infected tissues themselves.
So the environment is giving instructions.
Yes, exactly.
Guiding the activated T helper cell to become the most effective type for that specific situation.
Precisely. For example, if the infection is caused by an intracellular pathogen, like a virus that infects cells, the environment will be rich in certain cytokines that push the activated T helper cell to become a Th1 cell.
T1.
Yep. Th1 cells are the body's main defense against these types of threats.
Got it.
They produce a key cytokine called IFN gamma or interferon gamma.
IFN gamma.
And here's a key insight: therapies that boost IFN gamma might be really effective against those viral infections.
Right.
But they could potentially worsen autoimmune conditions that are driven by too much Th1 activity.
Oh, so it's a double-edged sword.
Exactly.
What exactly does IFN gamma do? This sounds like a crucial player.
It is. IFN gamma has several critical jobs. It activates macrophages, which are like the Pac-Man of the immune system, enhancing their ability to gobble up and destroy those pathogens.
Right.
It also boosts the killing power of CD8 plus T cells, which are those cytotoxic T cells, the body's assassins that can directly kill infected cells.
So they're like the special forces.
Yes, exactly. And interestingly, Th1 cells are also involved in forming granulomas.
Granulomas.
Yeah, these are basically walls of immune cells that the body builds to contain persistent threats.
Oh, wow.
In chronic infections. It's like a way to wall off something it can't completely eliminate.
Interesting. So Th1 cells are focused on dealing with threats inside our own cells.
Right.
What about Th2 cells? What do they do?
The H2 cells are crucial for fighting off extracellular pathogens like helminths
Oh,
or parasitic worms. They're often too large for those macrophages to engulf.
okay.
To combat these big invaders, they produce a different set of cytokines, including IL-4, IL-5, and IL-13.
Okay.
These cytokines activate eosinophils, another type of immune cell that's really good at fighting parasites.
Got it.
However, those same cytokines, particularly IL-4 and IL-13,
Okay.
also promote B-cell class switching to produce IgE antibodies, which are the major players in allergic reactions.
So Th2 responses are linked to both parasite defense and allergies.
Exactly. It's the same underlying mechanisms at play,
Okay.
just triggered by different things.
Interesting. So Th1 cells are more about cellular warfare,
Yes.
and Th2 cells are more about antibodies.
Right. Th2 cells favor a more humoral approach with antibodies produced by those B cells triggered by IL-4 and other cytokines.
Okay.
It's fascinating how those pathways overlap.
It is fascinating. A little inconvenient for those of us who suffer from allergies.
Absolutely.
What about Th17 cells? What's their role?
Th17 cells specialize in defending against fungal and certain bacterial infections,
Okay.
particularly at barrier surfaces like your skin and mucous membranes, which are common entry points for these types of pathogens.
Makes sense.
Their signature cytokine is IL-17.
IL-17.
Yeah, and it's a potent pro-inflammatory molecule. It promotes inflammation and, importantly, recruits neutrophils to the site of infection.
Neutrophils.
These are like the first responders of the immune system.
Okay.
Crucial for clearing many bacteria and fungi.
So Th17 cells are calling in the reinforcements.
Yes, exactly. They're bringing in the first responders.
Okay. Now let's move on to T-phage cells.
Okay.
T follicular helper cells.
Uh-huh.
Even the name suggests they have a very specific location and job.
You're right. They do. TFA cells are essential for helping B cells within the germinal centers of lymph nodes.
Germinal center.
These germinal centers are like specialized training academies
Right.
where B cells mature and refine their antibody production after encountering an antigen.
Hello.
TFA cells produce cytokines that promote B cell proliferation, meaning they help them make more B cells.
Got it.
They also help them undergo class switching, which means changing the type of antibody they produce to be most effective against the specific threat.
Okay.
And ultimately, this leads to the production of high-affinity antibodies, meaning antibodies that bind really tightly and specifically to the pathogen.
Oh, so they're like super antibodies.
Yeah, you can think of them that way.
Okay.
They're highly targeted weapons in the immune arsenal.
So the TF cells are the coaches for the B cell antibody response.
Yes, exactly. They guide the process within those lymph nodes.
Okay. Lastly, we have regulatory T cells or TREGs.
Ah, yes, TREGs. They're absolutely vital for keeping the peace.
It sounds like they have a crucial job preventing friendly fire.
They do. Regulatory T cells, or TREGs, are essential for maintaining immune tolerance and preventing those autoimmune attacks.
Got it.
They actively suppress the activation and function of other immune cells,
Okay.
including other T cells. Think of them as the body's natural brakes on the immune response.
They're keeping everything in check.
Exactly. They help dampen down inflammation after an infection has been cleared. And most importantly, they prevent self-reactive T cells, the ones that might have slipped through negative selection, from causing harm to the body's own tissues.
Wow, so they're like the peacekeepers of the immune system. And the notes say that a deficiency in TREGs is actually a central mechanism in many autoimmune disorders.
That's right, which is why TREG-based therapies are a really hot area of research right now.
It makes sense to try and boost their numbers.
Yes.
Okay, so we've got all these different subsets of T helper cells, each with their own specialized job description.
Yep.
What do they actually do once they're specialized and deployed?
Okay, so once they've differentiated, these T helper cell subsets get to work executing their specific functions.
Okay.
Th1 cells, as we discussed, release IFN gamma to supercharge those macrophages and support the activity of the cytotoxic CD8 plus T cells.
Right.
Essentially, they're amplifying the cell-mediated immune response, which is the arm of the immune system that deals with infected cells and intracellular pathogens.
Got it. So what about the Th2 team? What do they do?
The H2 cells go about activating eosinophils and basophils, which are key players in defending against those parasites.
Right.
They also stimulate B cells to churn out IgE antibodies, which, as we know, are central to allergic responses, triggering the release of histamine and other inflammatory mediators that cause those familiar allergy symptoms.
So their actions directly explain the symptoms we experience, during an allergic reaction.
Exactly.
What about Th17 cells? What do they do at this site of infection?
Well, through the release of IL-17,
Yeah.
Th17 cells mainly recruit and activate neutrophils to the site of infection.
Right.
Those neutrophils engulf and destroy bacterial and fungal invaders.
Got it.
But it's important to note that if Th17 activity gets out of control,
Okay.
it can contribute to chronic inflammatory diseases. So again, we see that delicate balance.
Right. Too much of a good thing can be bad.
Yeah, exactly.
And what about TFA cells? We know they help B cells in the lymph nodes.
Yes.
But what's their direct action on those B cells?
Their main action is through the cytokines they secrete within those germinal centers in the lymph nodes.
Okay.
These cytokines act like guiding signals telling the B cells to proliferate, meaning make more of themselves, undergo class switching to the best antibody type,
Right.
and go through affinity maturation, which means fine-tuning those antibodies
Got it.
to bind even more tightly to the pathogen. So they're not directly attacking anything themselves,
Okay.
but they're essential for making sure those B cells produce the highest quality, most effective antibodies.
So they're like these strategic advisors for B cell antibody production.
Exactly.
And finally, what about the TREGs? How do they actually suppress the immune response when it's time to call things off?
TRIGs use a variety of mechanisms to suppress immune responses.
Yeah.
They can release inhibitory cytokines like IL-10 and TGF-beta,
Oh?
which act like dampeners, reducing the activity of other immune cells.
Okay.
They can also directly interact with other T cells and APCs,
Got it.
inhibiting their activation and function through cell-to-cell contact.
So they're actively working to maintain that balance.
Exactly. It's all about maintaining immune homeostasis,
Right.
preventing excessive inflammation, and those autoimmune reactions.
It's incredible how these seemingly simple cells manage to coordinate.
I know, it's amazing.
Such a complex and finely tuned orchestra of defense and regulation.
It really is.
The notes emphasize that T helper cells are not just about activating the immune response.
Yes.
They also play a crucial role in regulating it,
That's a key point.
making sure it doesn't stay on indefinitely or overreact. How do they do that?
Well, the balance between the different T subsets is really crucial here.
Okay.
For example, the balance between Th1 and Th2 responses needs to be carefully maintained.
Uh-huh.
If the immune system leans too heavily towards a Th1 response,
Okay.
it can sometimes lead to too much inflammation and tissue damage.
Right.
Conversely, an overactive Th2 response, as we discussed, is linked to allergies and asthma.
Got it.
So the immune system is constantly adjusting this balance based on the type of threat it's facing.
That's constant balancing act.
It is a dynamic equilibrium.
And what about the link between Th17 cells and autoimmunity?
Right, so while Th17 cells are important for defense, their pro-inflammatory nature means that if their activity isn't properly controlled,
Uh-huh.
they can contribute to the development of autoimmune diseases.
Okay.
Like conditions like multiple sclerosis and inflammatory bowel disease
Right?
have been linked to an overactive Th17 response.
So again, it's about that balance.
Exactly.
And TREGs are immune peacekeepers.
Yes.
Play a central role in this regulation, right?
Absolutely. They are the cornerstone of immune tolerance.
Okay.
They're constantly working to prevent those autoreactive T cells from attacking the body,
Right.
and they're crucial for resolving inflammation after an infection is cleared.
So they're stepping in to calm things down.
Exactly. Preventing chronic inflammation and maintaining that self-tolerance.
They're essential.
They are.
It's really amazing how these seemingly simple cells can orchestrate such complex responses.
I know, it's mind-blowing.
So to recap our deep dives into T helper lymphocytes,
Yes.
they begin as basic progenitor cells in the bone marrow,
Right.
then travel to the thymus for their education and those crucial selection processes. They get activated when they recognize specific threats in the presence of those co-stimulatory signals.
Yes.
And then they differentiate into a variety of specialized helper roles.
Right.
Th1, Th2, Th17, TFH, and TREGs,
Yeah.
each equipped with their own specific tools and actions.
Exactly.
And importantly, they're not just about attacking invaders.
Right.
They're also crucial for regulating the entire immune system,
Absolutely.
maintaining that balance and preventing it from turning on our own bodies.
A crucial role.
That's the incredible journey and multifaceted role of a T helper cell.
It is. And I think the aha moment here
Yes, it
is realizing how these tiny cells, through a series of carefully orchestrated steps
Right.
and interactions, can coordinate such complex immune responses.
It's really remarkable.
It highlights the elegant and sophisticated design of your body's defense system.
It really does. And understanding T helper cells isn't just some abstract biological concept.
No, not at all.
It has real-world relevance for our health.
Absolutely. Understanding T helper cells is fundamental to understanding immunity,
Right.
how your body fights off infections and stays healthy.
Okay.
It's also key to understanding allergies,
Mm-hmm.
autoimmune diseases, and even how new therapies are being developed,
Right.
many of which target specific T helper cell subsets
Sure.
or the signaling pathways they use. So for you, the listener,
Yeah.
understanding this activation process is key to understanding how vaccines work.
That's a great point. Vaccines are all about triggering a specific immune response
Exactly.
that these T helper cells then help to orchestrate.
Right.
So as you go about your day, think about this.
Okay.
How might subtle disruptions in the balance of these different T helper cell subsets
Yeah.
contribute to the vast array of health issues we face? It really makes you appreciate the complexity of the immune system and all the ongoing research in this field.
Sure.
Thanks so much for joining us on this deep dive into T helper lymphocytes.
It was my pleasure.
We'll see you next time.